Hello you guys, welcome to today's lesson on graphing linear inequalities. Before we get started, make sure you have a piece of paper out, something to write with, and something, and a calculator, those three things. So piece of paper out, something to write with, a calculator. If you do want to print your notes guide, you can do that by going to the course, and then this is the lesson on graphing linear inequalities. So remember that inequalities are different from equations in that inequalities have these symbols: less than, greater than, less than or equal to, greater than or equal to. And before we move into graphing linear inequalities, there are some things that I would like to review with you. The first thing is that when we are talking about linear equations, we have to remember that linear equations can have an x, or they can have a y, or they can have an x and a y. Linear equations will not have either variable raised to a power higher than 1. Linear equations will not have the x or y in the denominator of the fraction. After we learned about linear equations in this class, we learned about how to graph linear equations. And in this class, you have learned that there are 3 ways to graph a line. The first one is to put your equation into standard form and find the x and the y intercepts by letting the y be 0 and solving for the x, and letting the x be 0 and solving for the y. Another way that you learned to graph a line was to solve for the y and set up a table of values and find at least 2 points on the line. And then the third way that you learned to graph a line was by using slope-intercept form. Let me give you an example of each of these 3 ways to graph a line. So if we want to graph a line using standard form, remember our standard form is a times x plus b times y equals c. So if we're going to graph a line using the x and y intercepts, we put our equation into standard form, which is this form right here. And then we find the x-intercept and the y-intercept. That gives us 2 points that are on the line that we can then graph. So let's go ahead and take this equation right here. 6 times x equals 2 times y equals 8. And let's put it into standard form. Remember, in standard form, you have the term that has the x and the term that has the y, both on the left side of the equation, and then your constant term is on the right side of the equation. So when we look at this equation right here, we have our x term is on the left side of the equation. We have our constant term that's on the right side of the equation. So those 2 terms are where they need to be. But we need to move this 2y to the other side of the equation. So the way that we're going to do that is we are going to subtract 2y from the right side. That's going to eliminate this term from the right side, and then whatever you do on one side, you have to do the exact same thing on the other side. So we subtract 2y from the other side, which leaves us with 6 times x minus 2 times y equals negative 8. Okay? Now, from there, to find the x-intercept, we're going to let the y-coordinate be 0, and then we're going to solve for the x. So let's take our equation, 6 times x minus 2y equals negative 8, and let's let our y be 0. So 6 times x minus 2 times 0 equals negative 8. And now from here, we know that negative 2 times 0 is 0, so that gives us 6 times x equals negative 8. And then we would divide by 6 on both sides. So we get x equals negative 8 divided by 6. Okay, so let's go ahead and simplify this fraction. We know that 2 goes into negative 8 negative 4 times, and 2 goes into 6 3 times. So x equals negative 4 thirds. So when we find our x-intercept, it would be negative 4 thirds, comma 0. So let's go ahead and plot our y-intercept. So negative 4 thirds as a mixed number, if we change negative 4 thirds into a mixed number, this is going to be 1 and 1/3. So negative 1 and 1/3. So that is our x-intercept. This is our x-axis. Okay, we know that our line is going to cross through the x-axis at negative 1 and 1/3, which would be about right here. So negative 1 and then 1/3 of the way to negative 2. Make that a little bit bigger here if I can. Okay, so negative 1 and 1/3. Now let's go ahead and find the y-intercept by letting the x be 0. So to find the y-intercept, we are going to this time let the x be 0 and solve for the y. So let's take this equation 6 times instead of the x. We're going to let that be 0. Then we have negative 2 times y equals negative 8. And then we would divide by negative 2 on both sides, because this 6 times 0, we know that that's just going to be a 0. So that'll just totally cancel out, which leaves us with negative 2 times y equals negative 8. Divide by negative 2 on both sides, and y equals positive 4. Okay, so when our x is 0, our y is 4. So that is our y-intercept. Once we have the x-intercept and the y-intercept, we can graph our line. Okay, so let's review graphing using a table of values. So when you graph using a table of values, you set up your table of values. We know that our equation is y equals negative 2x minus 1. So we want to find at least 2 points that are on this line, and then we can plot those 2 points and graph our line. So let's go ahead and let the x be 0. Okay, so remember when you're graphing using a table of values, you just pick some values for x, whatever you want, and then you substitute those in the equation for the x, and you solve for the y. Okay, so if we let the x be 0, negative 2 times 0 is 0. 0 minus 1 is negative 1. So when the x is 0, the y is negative 1. So that gives us an ordered pair of 0, negative 1. So let's go ahead and plot that point. 0, negative 1 would be right here. Let's let the x be 1 this time. So if I take this equation, negative 2 times instead of the x, if I let that be 1, we get negative 2 times 1, which is negative 2, negative 2 minus 1, which is negative 3. Remember that it is really important that you use your calculators when you are plugging in to these equations. Okay, make sure you're always using your calculators for your integer operations. So 1, negative 3, that would be to the right 1, down 3, 1, negative 3. And then let's go ahead and find one more point here. Let's let the x be a negative 1 in this case. So negative 2 times negative 1 is minus 1. And remember, I'm just picking anything that I want for the x and then solving for the y. So negative 2 times negative 1 is 2. 2 minus 1 is 1. So when the x is negative 1, the y is positive 1. You can see that all three of these points line up in a straight line. This is our line. Y equals negative 2x minus 1. Okay, let's go ahead and review how to graph using slope-intercept form. So when we graph using slope-intercept form, remember we solve our equation for y. We get the y all by itself, and then we identify our slope. which is the coefficient of the x term, and we identify our y-intercept, which is the constant, and the y-intercept is where a line is going to cross through the y-axis. We always plot the y-intercept first, and then we use our slope. So let's solve this equation, x equals negative 2y plus 4 for the y. Okay, so in order to get this y by itself, we're going to need to subtract 4 from both sides, which leaves us with x minus 4 equals negative 2 times y. Then we're going to have to divide everything by negative 2. So x, remember this is a 1x, divided by negative 2. And then a negative 4 divided by a negative 2 is a positive 2 equals y. And then in order for this to be in slope-intercept form, I'm just going to switch this around. Okay, so now our equation's in slope-intercept form. Remember that whatever's in the place of your b, that is your y-intercept. So our y-intercept is 2. We're going to go up to 2 on the y-axis. I better do that in a different color. Let's do that in black. So we go up to 2 on the y-axis. That's our y-intercept. And then we use our slope, which in this case is 1 over negative 2. It's 1 over negative 2. So that means from our y-intercept, our top number tells us we're going to move up 1. Our bottom number tells us that we're going to move to the left 2. So we move up 1, to the left 2, up 1, to the left 2, and there is our line. Okay, and we did a graph of that line using slope-intercept form. Now, every time we draw a graph of the line is going to divide the coordinate plane up into 2 different parts. Okay, so this will be half of the coordinate plane, and this will be half of the coordinate plane. Okay, when we're looking at this side of the line, we would consider that above the line. Okay, and if we're looking at this side of the line, this side of the half plane, we would consider that below the line. So now that we've had a little bit of a review about the 3 different ways that we can graph a line, we are going to go through the steps for graphing a linear inequality. So graphing a linear inequality is going to be just like graphing a line that has an equation, except for instead of an equal sign, you are going to have inequality symbols. Okay, so we talked about that in the very beginning of the lesson. The method that we're going to use to graph each linear inequality is we're going to graph using slope-intercept form. I feel like that's the easiest way to graph. So when we graph a linear inequality, we're going to use slope-intercept form. So that means we're always going to solve for y. We're going to get our equation into, or our inequality into slope-intercept form. And remember that these symbols right here are going to be inequality symbols instead of an equal sign. So once you have your inequality into slope-intercept form, you need to look at your inequality symbol to determine whether your line will be dashed or solid. So if your symbol for your line is just a less than or just a greater than, the line is going to be dashed. Okay. And if your sign is a less than or equal to or a greater than or equal to, your line is going to be solid. The third thing we need to know for graphing a linear inequality is when we graph a linear inequality, we are going to be graphing a solution area. So there's going to be more than one point that makes our inequality statement true. And so if the y is above, or the y is greater than or equal to, we're going to shade above the line. And if the y is less than or equal to, we are going to shade below the line. So I want you to have these notes And we are going to go through how to do this right now, and then these notes are going to make a little bit more sense to you. Okay, so let's go ahead and graph 2x minus y is less than or equal to 4 using the steps that we just talked about on the previous slide. So in order to graph this line using slope-intercept form, we need to put our equation into slope-intercept form. So we need to solve for this y right here. We need to get this y by itself. And can you guys see that there's actually a negative in front of the y, which makes it a negative 1y. Okay, so to solve for this y, our first step is to subtract 2x from both sides. So now we have negative 1 times y is less than or equal to, I'm just going to switch these two around, that we have negative 2x plus 4. And now we have to divide everything by negative 1. And remember that when you are solving an inequality, it's just like solving an equation, except for you have to remember if you divide by a negative that your inequality symbol flips. So because we divided by a negative 1, our inequality symbol is going to flip. And then we still have 2 over 1 x, and 4 divided by negative 1 is negative 4. So now we have our inequality into slope-intercept form. So in order to graph using slope-intercept form, remember we always plot our y-intercept first. So our y-intercept in this case is a negative 4. Okay, now from there we're going to use our slope to tell us how to move. So our slope says up 2 to the right 1. So up 2 to the right 1. Up 2 to the right 1. Now before I graph my line, I need to pay attention to my symbol to figure out whether my line is going to be dashed or solid. Okay, so can you see your symbol right here? Can you see your inequality symbol right here? It's a greater than. So if we refer back to our notes, if our inequality symbol is just a greater than, it's going to be a dashed line. So we're going to go ahead and do a dashed line here. Okay, and you can see that this line divides our coordinate plane up into two halves, right? We've got this side over here, which is below the line, and we've got this side over here, which is above the line. Okay, so after we've graphed our line, our next step is to do our shading of our solution area. Okay, so if you refer back to our notes, if the y is greater than, we are going to shade above. So because our y is greater than, we are going to shade above. So this whole area of our coordinate plane is shaded, this whole half. Okay, now this whole area that I have shaded in right here, this is our solution area. So what that means is that we could pick any point within this solution area and it will make our inequality statement true. So let's go ahead and just try it. I'm just going to pick a random point here. Let's pick a point at -2, +2. So let's go back to our original inequality statement. And then we are going to plug in -2, +2. And let's see if this makes our inequality statement true. It should, because this point right here falls within our solution area. So this is our x, this is our y. So 2 times -2 minus 2 is less than 4. 2 times -2 is -4. -4 minus 2 is -6. And we know that that is true. -6 is less than 4. So you can pick any point within this solution area right here, and that will make your inequality statement true. Okay, so this is our solution area. Now, this line right here is dashed. Okay, so that means that we can't pick a line, we can't pick a point that's on this line. This dashed line is not included in our solution area. If the line is solid, then any of the points on that line are included in our solution area. Okay, so let's go ahead and graph this linear inequality. We're going to go through all of the steps again. So remember, step 1 is to solve your inequality for y, to put it into slope-intercept form. So 2 times y minus 3x is less than or equal to 6. So to put this equation into slope-intercept form, we're going to add 3x to both sides. So 2 times y is less than or equal to, I'm just going to switch these two around because remember in slope-intercept form we want our x term written first and then our constant. And then from there we would have to divide by 2 on everything. So y is less than or equal to 3 divided by 2x plus 3. Okay, so now our inequality is in slope-intercept form. We're going to go ahead and graph. So first thing that we do is we plot our y-intercept. We know that this line is going to cross the y-axis at 3. And then we use our slope, which is 3 over 2. Right, so our slope is 3 over 2. That means we're going to move up 3 to the right 2. So from our y-intercept of 3, we move up 3. 1, 2, 3 to the right 2. Okay, now we have to look at our inequality symbol to determine whether our line is going to be dashed or solid. Okay, so because our inequality symbol is a less than or equal to, because it has the and or equal to part, our line is going to be solid. So that means that that is included in our solution area. We can pick a point on this line and it will make our inequality statement true. So the next thing we need to do is we have divided our coordinate plane into 2 half planes, right? So now we need to do our shading. And if our y is less than or equal to, we are going to shade below the line. Okay, so this whole area that I've shaded right here, this is our solution area. So that means we can pick any point within this area, or we can pick a point that's on this line because it's a solid line. That is also included in our solution area. And any of these points right here would make this inequality statement true. So let me just show you. Let's just pick a test point to make sure. Let's say we pick the point 5, 0. That's what's within our solution area. So 5 to the right, up or down 0. So 5, 0. So I'm going to go ahead and change this to white. We can see a little bit better with white. So let's take this inequality statement and let's plug in 5 for the x and 0 for the y, and make sure that that does make the statement true. So 2 times 0 minus 3 times 5 is less than or equal to 6. We know that 2 times 0 is 0. Negative 3 times 5 is negative 15. And it is true that negative 15 is less than or equal to 6. Okay? Let's try one more of these. Okay, so let's go ahead and graph this linear inequality by first solving for the y. Okay, and this time our term that has the y is over here on the right side. But we're still just trying to isolate the y wherever it's at. So we first need to get rid of the 12 by doing a subtract 12 on both sides. So negative 3x subtract 12 is greater than negative 4 times y. Then we're going to divide by negative 4 on everything And because we divided by a negative, our inequality symbol has to flip. Negative 12 divided by negative 4 is 3. And then we have negative 3 over negative 4, which is just a positive 3/4 x. Okay, now the y is by itself, and this is in slope-intercept form for the most part. We're just going to rearrange this, rewrite it so that it's y is greater than 3/4 x plus 3. And now we can graph. We know that this line is going to cross the y-axis at 3. That's our y-intercept. We know our slope is 3/4. So from the y-intercept, we're going to move up 3. 1, 2, 3. To the right 4. 1, 2, 3, 4. Our next step is to take a look at our inequality symbol. And if it is just a greater than or just a less than, our line is going to be dashed. So in this case, our line is going to be dashed. Okay, and now we need to, so now our line has divided this coordinate plane up into halves, right? This half and this half. So we need to figure out which half is our solution area. So we look at our inequality symbol again, and because it's a y is greater than, that means we're talking about the half that's above the line. Okay, so this is our solution area. Our line is dashed, so our solution area does not include points that are on this line, just points that are above the line. Okay, now at this point, you should be able to try one of these on your own. So I want you to push pause, try this one on your own, and then come back to the video and see if you did it correctly. Okay, so to graph this line using slope-intercept form, our first step is to put our equation into slope-intercept form. So we're going to get the y by itself by subtracting 2x from both sides. Now we have a negative y is greater than or equal to negative 2x plus 2. This is a negative 1 times by y. So in order for the y to be all by itself, we have to get rid of the multiplication of negative 1. So we're going to divide by negative 1 on everything. Remember, when you divide by a negative, your inequality symbol flips. Okay. Now that our equation's in slope-intercept form, we plot the y-intercept, which is at negative 2. Our slope is up 2 to the right, 1. From there, we look at our inequality symbol. If our symbol is greater than or equal to or less than or equal to, our line is going to be solid. Let's go ahead and graph a solid line here. Okay, and now we need to figure out where we are going to do our shading, or where our solution area is. So again, we go back to our inequality symbol, and our inequality symbol is a less than. The y is less than or equal to. So that means all of our shading is going to be on the bottom. Okay, this is the half that's going to be shaded. So our solution area includes any point that's on this line would make this inequality statement true, and then also any point that's within this solution area. One more thing I wanted to do with you before I give you your quiz is I want to make sure you remember how to graph a horizontal line and a vertical line. Remember that if you have an x equals equation, your line is going to only cross through the x-axis, and it's going to cross through the x-axis at this point. Okay, so when we're graphing, x is greater than 2. This symbol right here is just a greater than, so that means our line needs to be dashed. This is a vertical line going through 2 on the x-axis. Okay, and then x is greater than 2 then, so that means that any point that's within this area right here to the right is going to be our solution area, which makes sense. Okay, we know that 3, 4, 5, 6, 7, 8, 9, 10, right? Those are all greater than 2. And then if we want to graph a horizontal line, okay, if we only have a y in our equation, we do the same thing. We know that our line is going to go through -3 on our y-axis. It's just going to be a horizontal line. Because this is a less than or equal to, we know our line is going to be solid. And then this time we're going to shade below the line. So this is our solution area. Okay, so let's go ahead and review the steps for graphing a linear inequality, and then you guys are ready for your quiz. So step 1 is you're going to graph using slope-intercept form. So you put your line's equation into slope-intercept form. And then you look at your inequality symbol to determine whether your line will be dashed or solid. And then you look at your inequality symbol to determine your solution area, and you shade that area in. Okay, so here is your quiz. I'm really sorry that our video went over 30 minutes. I usually try really hard to make sure that it only lasts 30 minutes. So graph each linear inequality, 1, 2, 3. Make sure you turn both your notes and your quiz into the box, and have an awesome day. See you soon.